Hello everyone, JCE Connect. So in this particular lecture, I'll be discussing about a critical, subcritical and supercritical flow in a open channel. So how these terms to be defined? So what do you mean by critical flow, or what do you mean by subcritical flow, or supercritical flow? So these three things we can define based on the Froude number. When the Froude number is equal to 1, it is called as a critical flow. When the Froude number is less than 1, it is called as a subcritical flow. When the Froude number is greater than 1, it is called as a supercritical flow. Okay, so these particular things we have seen in a specific energy curve. When we draw a specific energy curve, so this is a specific energy curve. And one curve we get here like this. Then this will be E equal to Y, and this is E equal to Q square divided by 2G Y square, this curve. Then the resultant of these two will be this curve. Okay, and when we draw this resultant curve at one particular point, this one, when you draw a tangent here, the slope will be 0, and this particular point the energy of the flowing liquid will be minimum, that is specific energy is minimum. Corresponding to this energy, whatever the depth we call, this will be critical depth. And if you take at this critical depth, the Froude number is equal to 1. Then leaving this point you are marked as a C, leaving this point, wherever we take the points, you can take here or here or here, we get two alternate depths. That means when the specific energy is greater than the minimum energy, see, this is the minimum specific energy. When the specific energy is greater than the minimum specific energy, two depths are possible, here as well as here. So for the same energy, the energy will be same here. If you take this one, we get energy here, energy at 1. But energy at 1 can be obtained by having two different depths. Or for the discharge, for the constant discharge, we are getting the same energy, and that constant discharge can be passed in two alternate depths. The two alternate depths, how we are passing? One is by having a lower depth, this is 1 and this is 2. If I take this as a y1, one is a lower depth, other one is a higher depth, y2. Lower depth, higher velocity, higher depth, lower velocity. So the discharge can be passed in two ways: by lowering the depth, increasing the velocity, or increase the depth, lower the velocity, but energy remains same. These two depths are called as alternate depth. That is, when the specific energy is greater than the minimum specific energy, two depths are possible. One greater than the critical depth, one depth will be above the critical, and one depth will be the below the critical. One greater than the critical depth and other smaller than the critical depth. These two depths for a given specific energy are known as alternate depths. And the figure shows at any flows less than q max, there are two possible depths of flow, one greater than yc and other smaller than yc. So the depth above yc represents subcritical flow. That is, Froude number is we get less than 1, and below is Froude number greater than 1. The depth below critical represents the supercritical flow, and the depth above critical, the Froude number is less than 1, represents uh, subcritical flow. When we get a subcritical flow, as I said, the energy, minimum energy, sorry, the energy greater than the minimum energy, wherever we take, we get a two alternate depths. If we take this channel section, suppose this is critical depth yc. If we are getting depth of flow in this section, that is y1, then what happens here? Y1 is less than yc, but v1 will be greater than critical velocity. Okay, then one more way, if we take this one, this is yc, and here we get y2. Here y2 is greater than yc, and v2 is less than vc. Velocity is lesser than critical velocity. So this particular flow, here we get a supercritical flow, and here subcritical flow. Means for a given discharge, the discharge can be passed in two alternate depths, that is by lowering the depth, increasing the velocity, or increase the depth, decreasing the velocity. And here this is a Froude number, fr equal to 1, and Froude number is greater than 1, and Froude number less than 1. So based on the Froude number, we can classify critical flow, subcritical flow, and supercritical flow here. Okay, so examples, if you take a weir example, this is a weir. If the water is passing over the crust like this, in this, whenever the water is flowing through a crust, it is coming with a very high velocity, and suddenly when it comes and reaches the horizontal surface, it flows like this. Okay, it is means the flow here over the crust of the dam or crust of the weir will be supercritical flow. That is, Froude number is greater than 1. When it comes and contact with the horizontal surface, suddenly the depth gets changes. Here the depth increases, then at this particular point the Froude number will be less than 1. This becomes subcritical flow. Means the water from the steep slope, when the water is flowing or falling from the steep slope, it will be having very high velocity, which represents supercritical flow. When it comes in contact with the horizontal surface, suddenly the depth get increases, and that flow will be treated as supercritical flow. Then this depth changes suddenly here, that is when the flow changes from supercritical to subcritical. When the flow changes from supercritical to subcritical, then it is called as a hydraulic jump. Okay, then that hydraulic jump equation will be derived later, but try to understand what means the hydraulic jump. When the flow changes from supercritical flow, high velocity flow, to low velocity flow, high velocity to low velocity, then whatever the depth changes in a short period of time, that is called as a hydraulic jump. Okay, so supercritical means high velocity flow, subcritical means low velocity flow, and critical means a normal depth flow. Okay, so I hope you understood this one: critical, subcritical, and supercritical flow, and also alternate depths. alternate depths, alternate depths. So as I said, alternate depth means the when the energy is greater than the minimum energy in a channel, when energy is greater than minimum energy, we get two different depths of flow, and these two depths are called as alternate depths for any wherever you take section, here, wherever you take, leaving this point, wherever you take points on a curve, you'll be getting a two alternate depths, and those are called as alternate depths. Two depths, that is alternate depths.